In this video, we're going to calculate confidence intervals for means, and you should already be familiar with this concept when we went through it for proportions. And so when you're calculating confidence intervals for means, there are two scenarios you can encounter. The first is that you know your population standard deviation, and in this case, you're going to use a formula that has z star and sigma. But if you do not know your population standard deviation, then you need to use the t-distribution and s, which is your sample standard deviation. And so we're just going to go through some examples so that you can see how to calculate these intervals. So for our first example, of interest is to determine the mean age of all students attending VCU. The parameter of interest is mu, which equals the mean age of all students attending VCU. Assume that the standard deviation of the ages of all students is 5.3. Suppose that ages from a simple random sample of 20 students attending VCU is recorded, and the mean age of the sample is 22.7, and the standard deviation is 4.9. Estimate mu using a 95% confidence interval. So if you remember the 4 stages of a confidence interval, the first thing we need to do is identify all of our values. And so first, we know that we have a sample mean of 22.7. We also are given a standard deviation for the population, which is 5.3, but we're also given a sample standard deviation of 4.9. Now, even though we have a sample standard deviation in this problem, we know our population standard deviation, so we're going to find z star. And since we have a 95% confidence interval, our z star is 1.96. And we have a sample size of 20. So now we can move forward, and in our second step, we're going to check our assumptions. And so in this problem, we have a simple random sample which satisfies our first assumption. And then for our second assumption, which is the central limit theorem, this does not state if we have normally distributed data or heavily skewed data. So we're going to compare our sample size to 15. And since 20 is bigger than 15, we have another satisfied assumption. So now we can move forward with our actual formula. We're using z star and sigma since we have a known population standard deviation. And so you can just plug in all of the values into these formulas and get your upper and lower bound. And so just make sure if you are solving this without a calculator that you are plugging this in correctly and don't make any mistakes. However, if you do use the calculator, you actually don't have to compute the test statistic, and that's usually easier for students. So once you have your upper and lower bound, you just need to make sure you interpret the numbers. And so in these problems, we will state that we have 95% confidence that the mean age of all students attending VCU is between 20.38 and 25.02 years of age. Now let's look at one more example. Of interest is to determine the mean age of all students attending Virginia Tech. The parameter of interest is mu, which equals the mean age of all students attending Virginia Tech. Suppose the ages from a simple random sample of 30 students attending Virginia Tech is recorded, and the mean age of the sample is 21.5, and the standard deviation is 6.1. Estimate mu using a 90% confidence interval. So in this case, again, if we look for all of our values, x bar in this problem is 21.5. We do not have a population standard deviation, but we do have a sample standard deviation of 6.1, and we have a sample size of 30, but this time, because we have an unknown population standard deviation, we're going to use the t-distribution for our test statistic, and you should already know how to solve for t star for a 90% confidence interval, which in this case is 1.676. And again, if you have trouble finding these test statistics, if you use a calculator, you do not need to calculate these. And so once we have our values, we can check for the assumptions. In our problem, it states we have a simple random sample of 30 students, and this actually satisfies both of our assumptions. And so we can then move forward, and if you're going to use the formula, just make sure you properly plug in all of your values, and you can get your lower and upper bound. And then again, you need to interpret these values. So in this problem, we would state that we have 90% confidence that the mean age of all students attending Virginia Tech is between 19.61 and 23.39 years of age. And so in our next video, we're actually going to use the TI-84 calculator to find these intervals.